I'm thinking that how this program came, you know very well. It is very simple. Matching there, 1 plus decrement both, called recursion. Matching not there, right? Decrement any one, but we don't know which is the best one. So find both maximum of that. Right? This is the program. It is very simple. This is the meaning of dynamic programming. Dilemma there, do all. Dilemma there, do all. Let me analyze this. Let me analyze this program. Recursive program analysis. What is the meaning? Time complexity finding, space complexity finding. I will explain. See the time complexity finding. Can you help me one small line now? What is the small problem? Time complexity finding, how will you do? Time complexity finding, how will you do? Write the recurrence relation and solve. See this one. I think this is what is the answer? Stopping purpose constant, it's okay. Now can you help you now? Suppose assume that if you are lucky, can you help you now? In the recursive program, which is the important part? If part or else part, else, but two else there. This is also else, this is also else. Two else there, right? See the first else, see this one. Assume that you are lucky, every time matching is there. 1 plus decrement both, 1 plus decrement, see this one, see correctly. Right, this is the first sequence, it is the second sequence. Isn't that second sequence contain more symbols? See the answer. Every time matching, decrement both. When you decrement both, right, this is still having some symbol, but this is don't have. So one person having 0 symbol, another one having more symbol. I think this case, any one 0, return 0. So what is the meaning? Right, every time matching is there. LCS problem will give best case because of two else there. Only one else, right? Else only will give everything, but two else there, right? This is only for stopping purpose. If condition don't give any case, else only, but two else there. Every time matching. I think this kind of combination. So time complexity of this part, this is called best case. Time complexity is going to be what is the answer? Minimum of m comma n. Whichever is smaller, that is the answer. See this one. One person is still there, another person is over. Then stop the program because this case return 0. So always matching, time complexity best case will come minimum of m comma n. Recursive program, listen everyone, I am analyzing this algorithm. It is a recursive program. Recursive program analyzing is nothing but else part only. In the else part only, every case will come best case, worst case, average case. Because of two else, right? First else is giving best case. So time complexity is going to be minimum of m comma n. Right? Second part will goes to this else part will goes to worst case. Why? Some people are asking why? Because of here only one function call. Less time. Here two function call. Binary tree will come. More time. This is the worst area. This area worst case and average case. Please be careful. More function call, more time. Can you see in the binary search log n? Because what is the reason? Only one side you will go. But in the finding maximum minimum both the side you will go. So n time came. Right? So in the merge sort algorithm, both the side you will go. That is the reason n log n came. If you go only one side, maybe n will come. More function call, more time. See here less function call, less time, best case. Here more function call, more time will come. So how to find out time complexity of this one? Write recurrence relation and solve it. Write recurrence relation. This also. Right? Some people are asking, sir, here also recursion. Why don't you write recurrence relation? Same thing I done. Every time see this one, every time decrement both. Recursion only, every time decrement both. If you want, you can write recurrence relation, you can solve, no problem. Meaning is same. This will give best case because of less function call. It will give worst case, average case because of more function call. Because most of the time whenever LCS is going on, this area you will come. It will goes to worst case and average case. Let me write worst case and average case. Let me analyze now. How to analyze the recursive program for time complexity? Write recurrence relation and solving. I am writing. See this one. Listen everyone now. Make sure that everyone listen. T m comma n is equal to time complexity of, see this one, time of LCS of m comma n. T m comma n is equal to time complexity of LCS of m comma n. Then see this one, then recurrence relation, see this one, then recurrence relation. T m comma n is equal to, can you see the else part? What is the answer? Then see this one, T m comma n is the time complexity of LCS of m comma n. What does it mean? The time complexity of this one is T of m comma n. LCS of m comma n, time complexity T of m comma n, if it is true, right? LCS of m minus 1 comma n. What is the answer? T of m minus 1 comma n. Otherwise this one, T of m comma, right, n minus 1. Next one more thing, see this one. I think recursion will take recursion, it's okay. See this one, if you want you can check. No loop, nothing. Which will take constant. This is going to be one function cost. See this one. After recursive calls are over, whatever is left out, that is going to be one function cost. See this one, this function cost is equal to constant, but right, this function cost is going to be constant, it's okay, but before that some work also there, which will take recursion, right? Let me write now. T m comma n is equal to, in the else part, what is the first one? T m minus 1 comma n plus T m comma n minus 1 plus constant. This constant is came because of this left function call this one, right function call this one, right, like this. So this is the recurrence relation for time complexity. Please say this one, T m comma n is time complexity of LCS of m comma n. Recurrence relation I written this one. If you solve this recurrence relation, you will get the answer. Some people are asking, right, how to solve this one? Using recursive tree method you can solve. Within few minutes I will do that also. If you have doubt, you will get the idea. Right, using, see this one I am writing, using recursive tree method, solve it. I will do that within a few minutes, solve it, you will get the answer. So this recursive program time complexity, right, I think because of, right, two L's there, one will give best case, one will give worst case, average case. Why it will give more time is more recursive call, why it will give less time is less recursive call. How much time? This is the idea. Every time decrement both. So one group is over, one group is not over. So that indication that problem is solved this. So minimum of m comma n. Worst case is going to be write the recurrence relation, solve. This is also same. I written the recurrence relation, I solved because of only one function call. Straight line came. Straight line. Because of two function call. Maybe binary tree, recursive tree method will come. Using recursive tree method, solve it. Right? How to solve that one? Within few minutes I will do using, right? Right? So using recursive tree method and all, please be careful. Can you help me? One function cost constant. But before that, right, there is some recursive call. Recursive calls will take recursive story, but this function cost is, one function cost is constant. Please be careful because no loop. Right? Some people are asking me how to solve that recurrence relation. Using recursive tree method you can solve. There is no problem. T of m comma n is the time complexity of LCS of m comma n. So I written the recurrence relation using, see this one, using recursive tree method, solve it. Right? Because of recursive tree method I will solve here. Right? It is going to be very simple. Let me check. How to solve I will explain using recursive tree method. See the answer, make sure that everyone listen. I am starting. Recursive, indirectly, directly I am doing recursive tree method only, you don't worry. Right? See the one example. Careful, please be careful from here. See this one. X is equal to 1, 2, 3 symbols. Y is equal to 1, 2, 3, 4 symbols. It is triple A, it is the 4 B's, X is equal to 1, 2, 3 triple A, Y is equal to 1, 2, 3, 4 B's. Right, everything is fine now. Now let me check. See this one, I think if you observe clearly, right, there A's are there, here B's are there, nowhere matching. So indirectly, directly I am doing recursive tree method only. To do that I am explaining this problem. Right, let's see this one. So x goes to, what is the answer? Triple A, y goes to, right, 4 B's. Now see the answer. See the answer, how the recursive program calling? Careful listen. LCS of x contain how many symbol? 3. Y contain how many symbol? 4 symbol. X contain 3 symbol, I am at the third symbol. Y contain 4 symbol, I am at the fourth symbol. Please check. Right? Both the symbols are matching or not, please check. I think no matching. So what is the answer? If no matching, which part you will go? If part or else part? Else part. Else part means what? No matching. You may decrement first one or decrement second one. Decrement first one. What is the answer? LCS of 2, 4. You may decrement second one. LCS of 3, 3. Right? Like that. Again this also same. Right? Again this also same. What is the answer? Second symbol, fourth symbol. Second symbol, fourth symbol. Again no matching. See. Every time no match. This area. So what is the answer? LCS of 1, 4. This one. It is the 1, 4. This one 2, 3. And one more, let me expand. Always you concentrate, leftmost path, rightmost path, expand. Right? Because those will give some guidance to us. You don't worry at all. Leftmost path, rightmost path, please expand. So let me try this one. What is the 1, 4? What is the 1, 4? LCS of 1, 4. What is the answer? 0, 4, 1, 3. Because of, see this one, because of one person is 0, stop. Right? But this one still going. I want to know how many levels there in this tree. That is the reason. So because of he stopped, I am going here. Otherwise I could have continued. He is still going. Means some more levels may come. Let me check. 1, 3. What is the answer? 0, 3 or 1, 2. Because of he stopped, I am going here. What is the answer? 0, 1, 1, 1. Because of he stopped, I am going. What is the answer? 0, 1, 1, 0. Because of both stopped, stop. It is the leftmost path I expanded, right? Let's go this also. Leftmost one, rightmost one. See this one. Let me expand this also. 3 3. What is the answer? 2 3. This is 3 2. Rightmost path only. See, leftmost path I done, rightmost path. What is the 3 2? Same. 2 2 3 1. Next one, this also. What is the answer? 2 1 3 0. Because of it is 0, come here. What is the answer? 1 1 2 0. Because of it is 0, come here. What is the answer? 0 1 1 0. Right? See this one. I think both are stop. Now can you help me? How many people will go? How many people will go? This is the M. This is the N. Can you help me now? This is the M, this is the N. It's okay. What is the M plus N? 7. If you want, you can check. 7 level tree. See this one? 1 2 3 4 5 6 7. 7 level tree. So what I want to say indirectly, directly. See this one. LCS of M comma N will generate. Careful listen. LCS of M comma N will generate M plus N level tree. LCS of M comma N will generate M plus N level tree. Some people are asking how. See this one. What is the first function called? M decrementing. What is the second function called? N decrementing. See this one. First one means what? Left one. See this one. 3 becomes. See this one. First one means left one. 3 becomes 2. 2 becomes 1. 1 becomes 0. When it is 0, this will start. When it will 0, then E will start decreasing. Right? What is the answer? 3. Right? 2, 1, 0. Like that. First M will decrement. Right? Whenever M 0, then N will decrement. Finally, M plus N level tree came. Right? I think this also same. I think this side who is decrementing? N. 4, 3, 2, 1, 0. Whenever E will become 0, right, E will start decrementing. 2, 1, 1, 1, 0, 1. So what is the answer? Until here is M decrement. Afterwards, N decrement. Overall is M plus N. Same here. This side is N will decrement. Right? This side is M will decrement. Overall, this side also M plus N. Right? If you want, only for namesake, right? Only for namesake. Few more levels, let me expand. Intermediate also. Always you concentrate. If you want to complete this entire story within less time, leftmost one, rightmost one, expand. My goal of drawing this tree to know how many levels there. So, suppose if anyone says, sir, I know how many levels there without drawing, that is also okay. If you know why, you will draw again. Suppose LCS problem in the gate examination came, don't draw the tree because you know M plus N levels. Some people are asking, sir, why M plus N came? What is the answer? See this one. First function called M only decrementing. Second function called N only decrementing. Overall M plus N decrementing. Overall M plus N. From today onwards, if anyone asks you LCS problem, LCS of M comma N, how many level tree will come? M plus N level. If anyone know how many level will come, right, you no need to draw. If you don't know, take one example like this and you draw. And one more. There is some advantage, right? Expand leftmost one, rightmost one, you expand, it's okay. I am okay with that. Leftmost one, rightmost one, you expand. But see this one. Until few levels, middle also you expand. Until few levels, middle also you expand. Let me expand. What is the answer? 2 3. Same. What is the answer? 1 3 2 2. What is the 1 3? 0 3. 0 3. What is the answer? 1 2. What is the 2 2? 1 2 2 1. What about 2 3? 1 3 2 2. Right? So I think this also expanded. This also expanded. What is the 2 2? 2 2. Only for namesake I expanding. What is the answer? 1 2 2 1. Like that. Right? Few levels you expand. No requirement of many levels. Few levels expand. It's okay. Can you help in how many people will go? Listen, interesting answer. Right? LCS of M comma N will generate how many level tree? M plus N level tree. Then one more thing I want to ask. See this one. LCS of M comma N will generate M plus N level tree. It's okay. And one more thing I want to ask you. Every function cost how much? Constant. See this one. This will give in this tree. This will give left function call. This will give right function call. Every function cost constant. Right? E will give. Some people are asking me, listen, this is something like recursive tree method. Can you help in how many level tree? M plus N level. Can you say, first level cost, C. Second level 2 function call, 2C. Next level 4 function call, 2 square C. Next one, 8 function call, 2 cube C. And so on, and so on. Can you say how many level tree came? Left side, right side, same number of levels. What is the answer? 2 power M plus N into C. M plus N level tree, 2 power M plus N into C. So indirectly, directly I want to say, whatever I done until now I am explaining now. See this one. I am analyzing this recursive program, right? I am analyzing this recursive program. Best case, minimum of m comma n, I am okay. This entire story what I am discussing, worst case and average case. Let me write. Worst case and average case I am explaining. So, time complexity of LCS of m comma n is equal to T of m comma n. Recurrence relation. What is the answer? T of m comma n is equal to left to this one, right to this one. Right? I think one function cost constant. If you solve using recursive tree method, can you help me now? How many level tree will come? You know, now only we done. The purpose of doing that tree to know number of levels. If you know number of levels, you go directly. If you don't know, do like that and come. M plus n level tree, can you see how many, what is the cost here? What is the cost? This is the cost here. See this one? This is the cost. 2 power 0 c, 2 power 1 c, and so on. 2 power m plus n into c. Right, 2 power m plus n into c. Finally, which will goes to what the answer? If you want, you can check 2 power m plus n into constant. Which will goes to what the answer? Order of 2 power m into 2 power n. Which is nothing but 2 power m plus n. This is the time complexity. So, time complexity of this recursive program, worst case and average case, this much. Can you see how many level tree? M plus n level tree. How you know? How you know? Using recursive tree method, I done. See this. One small example you take and do this. Small example, I also don't know, right? Whenever new problem is given, no one knows, right? Expand like this. Leftmost path expand, rightmost path expand. Just I done recursive tree method, nothing. If you know directly you write. Suppose isn't that? Directly you know m plus n levels, directly write. First level, see this one, first level C. Second level, these two will give 2 more C's. Next level, right? These two will give each 2, right? 2 square C and so on. How many level? M plus n. So this kind of series will come. So, time complexity of this recursive program, worst case, average case, 2 power m into 2 power n. Best case, minimum of m comma n, best case. This recurrence relation, whatever I am going to write, that is for worst case and average case. This is for best case. This is for best case. And one more interesting answer. Whenever you say it is the recursive program, stack space required. What is the stack space? Number of level, it is the stack space. Extra space or stack space? Let me write, stack space. How many level tree? M plus n level tree. What is the time complexity? 2 power m into 2 power n. How it is the time complexity? This one. See the definition. How it is worst case and average case? We written. Right? From this area we are writing. Fine. Next one. How you know m plus n level? Using recursive tree method. This one. How you know that m plus n? Leftmost one expand, rightmost one expand. You got to know m plus n level tree. So first level cost C. Second level cost 2C. And so on, how many level? M plus n, 2 power m plus n into c. If you solve this one, right, this particular series, if you add all of them, what is the answer? This particular series, if you add all of them, how much answer came? Answer is c into 2 power m plus n, which will goes to order of 2 power m plus n. So, like this. I am thinking you are almost okay, right? Listen, I am thinking you are almost okay. Now, can you help me now? Can you help me now? In this else part, what is the one function cost? Constant. How many function calls came? Almost these many function calls came. Every function cost is constant. So, 2 power m into 2 power n, right? So, one function cost constant, this area. Always it will come from this area. One function cost constant, these many function calls came from this area. 2 power m into 2 power n function calls came. So, time complex order of 2 power m, 2 power n. Next one, how many level recursive tree? M plus n level. So, stack space, extra space or stack space is going to be m plus n. Okay, I am thinking that until now you are really comfortable. Let me ask you one small line now. Right? The program, listen, the program whatever I written, the program which I analyzed, right? Until now whatever I done is, right? Recursive program to find out LCS, right? This recursive program, right? Whenever dilemma I cover every possibility. Please remember the recursive program whatever I written, this is a brute force method because covering all. It is a brute force method. Please be careful. Some people are asking me, sir, are you done until now dynamic programming or not? No. What is the meaning of dynamic programming? Dynamic programming is also looking like brute force. But in the dynamic programming, one condition. What is that one? If same person is coming again, don't do one more time. In this program, nowhere I verified, is it the same person coming or not. From now onwards, I will keep that condition also. In the recursive program, if you keep one condition, that is called a conditional recursive program, which is called dynamic programming. Same thing only, dynamic programming also same, just write one or two condition. What is that? From now onwards you will see. Until see this one, 90%, right? Brute force method, dynamic programming, same. Until now, whatever I done, it is the brute force method, almost 90% of the dynamic programming done. One condition you add, right? What is that? Same thing is coming again, don't do one more time. That is called dynamic programming. Right? So let's see one more line. See this one. Until now, whatever I done, brute force method only I done. LCS problem finding using brute force method recursion, I done this. Right? Now see the next step. See the next step. Some people are asking, sir, how will you go dynamic programming further? It's very simple. After completion of the brute force method until now, you have to do one thing. What is that? In the recursive tree, what you drawn, in that, is there any repetition or not? Check. It is a recursive program, a function calling that itself, it's okay. But in the recursive tree, what you drawn, in that recursive tree, whatever you drawn, in that any repetition there or not, let me check. Check here. Any repetition there or not? The recursive tree, whichever is there on the board, is there any repetition or not? Let me check here. Repetition is there or not? See this one, 2, 3, 2, 3. Repetition there. Next one, 1, 3, 1, 3, 1, 3, 2, 2, 2, 2, 2, 2. See, many places repetition. 1, 2, 1, 2, 1, 2. So many times, right? It is 2, 1. 1, 2, 1, 2, 2, 1, 2, 1. Many repetitions are there. So what I want to say, the recursive program, whatever you done until now, it is a brute force, it's okay. In that brute force, every possibility covered, but many times repeated. So in the recursive program, where repetitions are more, then you can go to dynamic programming. Some people are asking, sir, can I go to dynamic programming now? Yes, when you got to know, many repetitions are there, go to dynamic programming. So repetitions are not there, dynamic programming is not advisable at all. What is the dynamic programming behavior saying? If in the recursive program many function calls are repeating, right? Why are you doing many times? Do one time only. If repetitions are not there, some people are asking, sir, can I go to the every recursive program dynamic programming? No. First write the recursive program brute force. In that, if you identify many repetitions are there, then go to dynamic programming. So what should I do now? In the above recursive tree, many function calls are repeating. So I will go to dynamic programming so that, right, if anything repeating, I will do one time only. That is the next step. Now I think now students got one interesting thing. Even though it is taking some time and all, they are getting one interesting point. What is that? The point is, sir, why you written this tree? Until now some students want to ask me. The purpose of drawing this tree, two reasons. One reason is going to be, right? So in the LCS problem, LCS of m comma n, how many level tree will come? One more, repetition is there or not? Right? In the LCS of m comma n, how many level tree will come? And repetition is there or not? In the gate examination, LCS problem came. You no need to draw the tree. Why? You know number of levels are m plus n. You know repetitions also there. So directly you can do the normal story. If new problem came, please do like that. Can you help from now onwards? If any problem is given, which is the new, using dynamic programming, how will you do? What is the answer? Just to do first brute force method. How to solve that problem using brute force method you do. After completion of that, because of that is a recursive program, right? Just to write the reconciliation to solve the time complexity, right? Solve the reconciliation. In that recursive tree, how many levels are there, right? Those many level stack required. Suppose if you don't know how many levels, using recursive tree method, you draw. And one more, after completion of that, right? Reconciliation every time you solved everything, okay. Next one, can I go to dynamic programming or not? How to decide? Repetition is there or not? Verify. If repetition not there, why you go dynamic programming? Repetition there, same thing coming many times, do one time, that is called dynamic programming. No repetition, why you go dynamic programming? Some students are thinking that every recursive program, I will go to dynamic. No. Recursive program where repetitions are there, then go to dynamic programming. Is there any repetitions here? Yes. Then I can go to dynamic programming. Let me write now. See, I am writing here. Carefully listen this note. In the above recursive tree, many function calls are repeating. In the above recursive tree, many function calls are repeating. So, we will go to dynamic programming. In the above recursive tree, many function calls are repeating, so we will go to dynamic programming, which will solve distinct function calls. Distinct function calls. Right? Please be careful. So, some people are asking which will solve only distinct function call. Now, see the answer. Right? See the interesting one. One important question I want to ask you. It is very, very important. See this one. LCS of m comma n contain. See the important question. LCS of m comma n contain how many distinct function calls? Dynamic program is distinct only. How many distinct function calls? Distinct function calls. Right? We will find out. How to find out? I will give the answer. LCS of m comma n contain how many distinct function calls? I am giving the answer. See the answer. See the answer now. LCS of m comma n is in that m value is in that 10, n value is in that 5. LCS of m comma n, m is 10, n value 5. Now if you observe clearly, LCS of m comma n contain how many distinct function call? It's okay. M value 10, n value 5. If you observe the algorithm, what is the answer? M is going -1, n is going -1. Right? So let's see this one. Right? It is going -1. See this one. 4, 3, 2, 1, 0. Right? Next one. This also going -1. It will become 9, 8, 7, and so on. What is the answer? 1, 0. Can you help me now? This is how many ways? This is how many ways? 10 to 0 means how many? 11. This is how many ways? 5 to 0 means 6. Right? So which is nothing but this is m plus 1 time. This is n plus 1 time. You only say one work will be done m ways, another work will be done n ways. Both can be done at a time. What is the answer? M into n ways. So m plus 1 into n plus 1 distinct function call. These many distinct values are there. Right? See, whenever LCS is going on, this 10 becomes 9, 9 becomes 8, and so on until 0. Right? This n becomes 5 becomes 4, 4 becomes 3, and so on 0. So this total 11 ways, 10 plus 1. This total 5 plus 1, 6 ways. So m plus 1, n plus 1. Right? One work will be done m ways, another work will be done n ways. Both can be done at a time, m into n ways. So finally, right, forget about -1 plus 1, m into n distinct function calls. Distinct function call. This one. Distinct function calls. These many distinct function calls are there. M plus 1 distinct function call. Right? Now see the answer. Mn into one distinct function call will take constant time. If anyone don't know why it is taking constant time, you can see here. See this one. One function call will take constant. Distinct function call or some other function call doesn't matter. One function call will take constant time. Right? M into n distinct function call. One function call will take constant time. So time complexity of, see this one, time complexity of LCS of m comma n using dynamic programming order of mn. This is the time complexity. Using dynamic programming, this is the time complexity. Please be careful. It is the best case or worst case. Right? Try to remember it is the worst case and average case. Best case is minimum of m comma n. Right? That is the first else. This is right worst case and average case time complexity using dynamic programming. Using dynamic programming. Next one. Time complexity minimum of m comma n. Right? Best case. Using dynamic programming. It is the time using dynamic programming. Dynamic programming is distinct function call. From today onwards, if anyone asks you, dynamic programming, how to find out time complexity? What is the answer? Distinct function calls, find out. See, LCS of m comma n contain how many distinct function call? Calculate. Mn distinct function call. Every function cost how much from the program? Constant, order of mn, worst case, average case. Everyone know this tree for, the tree whatever I written, that tree for, right? The tree for best case or worst case, average case, worst case, average case. That only came. Best case similar. Order of mn time, worst case, average case time using dynamic programming, minimum of m comma n, right? Best case time. Dynamic programming is distinct function call. See this one. This is the story. From here onward, dynamic programming is started. From here, dynamic programming. What is the dynamic programming from here? In the above recursive, in the above recursive tree, many function calls are repeating. So we will go to dynamic programming, which will solve distinct function calls only. So next question, how many distinct function calls? Right, this is the way of analyzing. Right, whenever this program is going on, m will decrement -1 -1 -1, n will decrement -1 -1. If you see overall m plus 1 ways, overall n plus 1 ways, both can be done at a time, m into n ways. So mn distinct function call, one function call constant. So order of mn time, worst case, average case, minimum of m comma n, best case, time complexity using dynamic programming. Please be careful. Next one, see the interesting answer. See the interesting answer. Everyone listen, space. Using dynamic programming. The story is using dynamic programming. Please be careful. Using dynamic programming, extra space how much? Our concentration is extra space only because input is anyhow common. Right? Input anyhow common. So in examination they will ask you, right? Extra space means normally extra space only. When you are comparing to algorithm, normally we will comparing extra space only because input same anyhow. Algorithm to algorithm, the way of writing based on that, right? Extra spaces keep on changing. So using dynamic programming, what is the extra space? Please be careful. What is the extra space? Right? I think because of you are using the dynamic programming, it is a recursive program. So what is the answer? Stack and table. Stack plus table. It is also recursion. So stack required. How much stack required? M plus n level stack required. What is the table? How many distinct function call? How many? Mn distinct function call. So for every function call, one slot required. What is the answer? Mn table required. Mn size table. Using dynamic programming, extra space is going to be because of the recursion. Same thing like Fibonacci also. See, son, when you return the recursive program, right, with dynamic programming, without dynamic programming, both will take stack. Because initially nothing available. Both will take stack. So m plus n. But in the dynamic programming, table also required to store the distinct function call mn. So total extra space, order of mn. With dynamic programming, extra space is mn, right? Without dynamic programming, what is the extra space? We are already written. Extra space here only stack space. So m plus n. So can you help me know this program, the program whatever I written, this program is with dynamic program or without dynamic programming? Without dynamic program, because here there is no concept called checking not there. This is the normal program with the brute force, time complexity 2 power m into 2 power n. Right, stack space is m plus n. Same program if you write, right, using this condition. What is the condition? Right, if the same thing is repeating again, do one time only, right? So in the same program, if you keep this condition, then because of dynamic programming solving only distinct function call, right? Distinct how many? Count. After counting distinct, I got to know that mn distinct function call. What dynamic program will do? Distinct function calls are mn, right? So for every distinct function call, right, you will manage one slot in the table. So as soon as you compute any function call, store in the table mn distinct function call, mn table size required. Because of it is a recursive program, same program only attaching one condition. So stack space is m plus n. Overall is mn. Time complexity is a distinct function call into one function cost, order of mn. Right? Extra space. When you say space, normally space complexity means input plus extra. Normally space complexity means total space, input plus extra. But when you are comparing to algorithm, extra space only required. Mostly their concentration is extra space only because input is common in both the algorithm. Even though it is there, it is there in use because it is a fixed part. Right? So space complexity is going to be fixed part plus variable part. Fixed part is same because of, right? So input is same. Variable part, that program will take extra space how much? This program will take extra space how much? Like that you will compare both the algorithms. Normally space complex means input plus extra, right? But I seen many books, they are taking only extra space. Somewhere there is extra, right? Space complex means total they are saying, that is also okay, but they are saying one more way also. Right? Space complex means input plus extra, that is okay, but normally we will take extra space only because extra space only we will compare, we will decide which is the best algorithm. Right? Extra space, right? Extra space only important, that is the reason everywhere I am writing extra space only. Comparing to algorithm, extra space compare. Right? Fine. In every book they are taking extra space only into consideration because the fixed part anyhow fixed one, what is the requirement of doing again and again? right? Variable, I think, what is the answer? Extra part only they are taking. Anyhow, to this program with dynamic programming, right? What is the extra space? Mn. Without dynamic programming, what is the extra space? M plus n, right? I written also. Time complexity is one. When you say dynamic programming, right? Time complexity decreased a lot. See, 2 power m into 2 power n became, what is the answer? Simply mn. Space may be, space previously m plus n, right? Now it became mn. Space may be little bit increased, but time decreased a lot. How many distinct functions? Can you help me now? Can you help me now? Some students are asking one more interesting line also. The line is like this. Sir, this program, how will you convert? This program, how will you convert into dynamic programming program? See this one. LCS program without dynamic programming, this is the way of writing. With dynamic programming, how? In the previous application, I said to you. I am repeating again. See this one. LC, right? Dynamic programming is very simple. See how you will do. Can you help me now? Is it function call? See this one, with dynamic programming I am writing very simple. Is it function call? Yes, right? Here you have to write one condition. What is the condition? It is the function call, it's okay. Here you have to write one condition. What is the answer? Table of, in the place of LCS, table. LCS of m minus 1 comma n will store in table of m minus 1 comma n. Before going to call, ask one condition. What is the answer? Is it there in the table or not? Next one, before going to call this function, here also ask one condition. What is that? Is it there in the table or not? Here one condition, here one condition. Because of that condition, what happened is, if not there, then only call. If not there, then only call. Condition. A recursive program with conditions is known as dynamic programming. And one more, it is also recursive call. You will blindly call. Here you have to check. What you will check? Table of m minus 1 comma n minus 1 is equal to null. If null, then only call. If not null, don't call. Next one, table of m minus 1 comma n is equal to null, then call. And store also in the table. Next one, table of m comma n minus 1, right? Call, right? Not available, then call. Then store in the table, like Fibonacci. So simple, before every function call, check is it there or not there in the table. By adding those three, here one line, here one line, here one line. By adding these 3 lines, small statement, right? Time complexity 2 power mn into, it will become how much? Time complexity 2 power m into 2 power n. By adding those 3 conditions, simply mn. Right? Please be careful. I'm thinking that you are absolutely fine. Right? I'm thinking you are absolutely fine. Let me say one more small line. Carefully listen. Let me say one small line. This is also required. Can you help me? Until now, those people who disturbed a little bit also, final conclusion. Final conclusion. Let me say once. Those people who are having small doubt also, let me say one small line. This is called without dynamic programming. Without dynamic programming, time this much, right? Stack space this much. With dynamic programming, time mn, right? Extra space mn, right? Both the times and space here same, right? Now come here one small line. This also you listen. With this it is over. It is only for namesake. Please listen. Isn't that x is equal to triple A 1 2 3. Next one, y is equal to 4 b's 1 2 3 4, right? Next one, x contain how many symbol? 3, y contain how many? 4. Now see the answer. So because of as soon as you compute, you have to store in the table, right? You have to store like this one. See, x is equal to 1 2 3 3 2 1 0. Y contain 4 3 2 1 0. This is the table. Every one, m plus 1 into n plus 1, those many distinct function call, every distinct function call, right? One slot required. This is the table. As soon as you compute, you store. Initially all are null. As soon as you compute, you store. Initially are null. Everything initially, nothing is available. Next one. This one, table of means LCS. LCS of 0 4. Everyone, one person is 0 means answer is 0. These are the termination conditions. So this much big table required. LCS of m comma n. How many distinct function call? For everything one slot required. So m plus 1 into n plus 1 distinct function call. So mn table size required. Please be careful. Now can you help me know what is your goal? LCS of 3 4 you want to calculate. See this one. This value you want to calculate. Is it null? Yes. Is it null? Yes, means not available. Not available, then only call. Otherwise don't call. If it is available, I could have stopped. In the dynamic programming, every time this condition there. See, I written the program also. See this one. Every time, see here one condition. You want to call recursion? Please check. Is it there or not there in the table? Is it there or not there in the table? Please check. Every time if you keep on checking, that is called as the dynamic programming. So if you are lucky, available, don't call further. If you are not lucky, call like that. Now see the answer, one small line. See this one, right? See the answer. Assume that, see this one, assume that, right? Is he available or not? Check. So no, not available, not available. But one thing, match there. If match there, what will happen? Assume that every time matching. What is the answer? If every time matching, so 3, 4 I compared matching there. So 1 plus decrement both here. Right? Here matching there. See, answer is not there, it's okay, but matching there. So 1 plus decrement both means this one. So 1 plus this answer you add, you will get this. Right? 1 plus, if you want to get this answer, 1 plus matching is there, decrement both means this one. Suppose assume that here also not available, but match there. 1 plus decrement both means this one. Right? I think this one like that. So I think whenever matching there, you will see you need only diagonal elements. These only required. Whenever matching there, you will see only diagonal elements. Right? You will see only diagonal elements. Right? Please be careful. Matching there, diagonal only. Matching not there, what is the answer? Whenever matching, this is one, 3, 4, matching not there. What is the answer? 3, 4 becomes, what will happen? Whenever matching not there, 3, 4 becomes, what is the answer? 3, 3. Maybe this one required, or 2, 4, this one required. This one or this one required. In these two, maximum will come here. Matching not there, find this, right? Maximum of these two will come here. Matching is there, 1 plus this answer. Matching there always like this, matching not there, either this one or this one. Right? Please be careful. Matching not there, either this one or this one. Right? Like that. Matching there, always diagonal. I hope everyone is fine now. This is. And one more. See this one. Totally how many entries are there? Almost like mn entries are there. Totally mn entries are there. Can you help me now? Mn entries you have to fill. Mn entries you have to fill. Right? When you say mn entries are available, then this problem becomes, I think everything available, you can use it. Right, fine. Can I help you one small line now? How will you fill this table? Mn entries are there. How will you fill this table? Everyone know this table is nothing but a 2D array. This table is nothing but 2D array. While filling this table, you can fill row by row. You can fill column by column. If anyone asks you LCS problem, table, how it is filled, row major order also you can fill, column major order. At the end of the day, total table I have to fill. What is there in that? If I want to get final answer, total table I have to fill. So you can fill row by row also, you can fill column by column also. Finally, total table you have to fill. Right? Total table you have to fill. If someone asks you how this table is filled, what will you say? You can fill row by row also, you can fill column by column also, depending upon requirement. So table filling can be done. What is the answer? Row major order also, row or column major, you can fill the table. Row or column major order, we can fill table. Row by row you can fill. Column by column also you can fill. There is no problem. Total table you have to fill. You can fill whatever way you like. Right? Whenever matching there every time, diagonals only required. Whenever matching not there, right? Either this one required, this one required. Matching not there. This one find out, this one find out. See this one. Matching, carefully listen, matching not there. This one find out, maximum you take. But how will you get this one? What is the answer? Again this one, matching not there. This one find out, maximum. So what I want to say, if you want to get this answer, these two required. To get this one, these two required. So overall, total table required. So how will you fill the table? Whether you go row by row, column by column, it is up to you. Fill the total table, then this answer. After filling total table, what is there here? This answer is equal to maximum of these two. How you got this answer? Maximum of these two. How you got this answer? Maximum of these two. Right? Total, worst case, total table required. So that is the reason. Mn entries. Right? I am not calculating same thing how many times you calculated. Only distinct function I calculated. Distinct function calls are Mn. You have to calculate all distinct function calls. All distinct function calls you have to calculate. Which order? Row by row you will go, column by column you go, you decide. Okay, I am thinking that everything is fine. Listen, I am thinking that everything is fine. Can you help me now? With dynamic programming time, Mn. With dynamic programming extra space, right? I think extra space how much? Stack, because of it is also a recursion, stack m plus n. Table how much? M plus n, m into n. See, stack is going to be m plus n, stack is going to be m plus n, table is going to be m comma n, that is also okay. Table is going to be m comma n. This is the total extra space. Total extra space how much? Mn. Now see the answer. Using dynamic programming, stack space this much, table size is going to be mn, right? So overall space is mn. Now see the answer. Interesting answer. Same recursive program whatever I written, careful listen, same recursive program whatever I written, using dynamic programming, recursive program I written. If you written, listen, dynamic programming using recursion I written, right? Same program if you write non-recursive program if you write, recursive program I written, right? Using dynamic programming by keeping those conditions, it's okay. If you write equivalent non-recursive program, this space can be decreased to, see this one, minimum of m comma n space. This space can be minimized to minimum of m comma n space. From now onwards, if anyone asks you, it is a special one. Using non-recursive program, dynamic programming only, recursive program I written. When you say recursive program, stack required, table required and all, because you are checking table also, because of recursion stack also required. If you write the non-recursive program, right? So stack, right? Total space become minimum of m comma n. Please remember, it is a special note. Right? In core man, one line is there. What is that one? Time complexity of LCS problem using dynamic programming. Order of mn space. Order of mn extra space. Right? But prove that using non-recursive program, it can be minimum of m comma n space. There is a theorem also. It may be useful to you. That is the reason I written. It is a special case, right? Non-recursive program, nothing there. Same thing if you write in the form of a non-recursion, right? This much space will take, but time is same, because recursion, non-recursion don't decide the time, logic will decide. Can you help me now? If I don't say this line, what will you say? Right? LCS problem, extra stack space using dynamic programming, mn. Using non-recursive program, same dynamic programming recursion. If you write non-recursion, right, so space becomes, right, extra space becomes minimum of m comma n, right? Please be careful. So this is the story now. Can you help, what I done until now? Very simple. If anyone confused a little bit also, let me explain. Every time same story. Let me explain. First LCS problem. First I explain what is the meaning of subsequence. Few examples. Common subsequence. Longest common subsequence, some examples, manually I done, that is the first story. Second is going to be how to find out LCS, not manually, using some recursive algorithm. So because of it, the brute force method, dynamic programming something like until 97%, dynamic programming is like brute force method, right? So just keep on compare normally, matching there, 1 plus decrement both, matching not there, right? Matching not there, I mean dilemma first one or second one, right? Do both, maximum you take. Like that I done. So that recursive program I analyze it first. How to analyze? Finding time and space. How will you find out time complexity of recursive program? Write reconciliation and solve. Right? While solving, I got to know recursive tree method required. In that, how many levels there? So I done using one example. Right? I drawn the recursive tree to know how many levels there in that. One more thing, right? Because of it, the dynamic programming, right? Any repetition there or not? Yes. I know levels also. I know repetition there or not. So levels there. So using that levels, right? Recursive tree method I completed. This much time, this much extra space, right? Because of repetitions are there. Dynamic programming I done. Dynamic programming is distinct function calls I calculated based on the table size also came. Right? Fine. This is the story. This is the time complexity, this is the space. Normally space means input plus extra, right? When you are comparing two algorithm, extra space only we are comparing. So extra space only I written. Don't confuse. Next one. I think everything is fine now, right? Next one. How will you fill this table? How will you fill this table? How will you fill the table? Totally mn entries are in the table. How will you fill it? If you want this answer, no matching. These two required. This required. These two. This required these two, this required these two. What is the meaning? This table, total values required. So anyhow total value is required. How will you fill it? Either row major or column major fill. So row major or column major order you can fill this table. If at all always matching, diagonal elements are enough. Right? Fine. Next one more. Right? In Coreman one theorem is there, because of that reason I written. What is that one? Dynamic programming LCS will take extra space Mn. Right? If you write the recursive program, if you written the non-recursive program, this order of Mn space can be reduced to minimum of M comma N. Minimum of M comma N. Right? Fine. So this is the entire story. Let's see the next application of dynamic programming. 2 applications I done. I am thinking that almost you are okay. 2 applications I done, almost you are okay. Let's see the 0 by 1 knapsack problem. This problem you know very well. It is very easy also. See this example, one small example. See this one. To solve this problem manually I am doing. Manually I am solving this problem manually. What right? How many objects? 3 objects. Object 1, object 2, object 3. 3 objects. So let's see this one. All 3 objects don't take. All 3 objects don't take. So I think manually I am checking. 0 or 1 means what? You may take, you may not take, only few, right? One take or don't take. See this one. If you don't take any object, you will get 0 profit. If you take only first one, how much you will get? 120. It is feasible because it is not crossing capacity of the knapsack. If you take only second one, how much you will get? 80. It is also feasible. If you take only third one, that is also feasible. How much you will get? 50. If you take first one and second one, what is the answer? It is not possible because 8 plus 6 is 14, not possible. If you take second one, third one, I think 6 plus 4, 10, how much you will get? I think 130. 130, right? Fine. Next one. If you take first one and last one, how much? 8 plus 4, 12, not feasible. Right? Not feasible. So can you help me? If you take all, no chance. So can you help in all possibilities I covered? How? All zeros to all ones. Total 8 possibilities I covered. Is there any possibility left out? Please check. All zeros. I think see totally 8 possibilities. Right? So 000 to 111. 8 possibilities. Can you help in out of these 8 possibilities? Who are feasible? These. Best one, this one. It is the actual answer. To this problem, take or don't take. To this problem, optimal answer is going to be this one. 0, 1, 1, profit is 130. Manually I done. Let's solve this problem using greedy. Greedy means what? Shortcut. You know what is the shortcut also. What is the greedy shortcut? Let me solve this problem using greedy. Using greedy technique I am doing. See this one, how it is. You know very well. Per 1 unit weight, object 1 find the profit. What is the answer? 8 units 120, per 1 unit 120 by 8. How much? 8 ones 8, remaining is 4, 8 5s. So per 1 unit weight find out. Object 2. Object 2, what is the answer? 80 by 6. What is the answer? 6162, 63 is 18. I think 13.2, 63 is 18. Right, something like that. Object 3. Object 3, what is the answer? 50 by 4. What is the answer? 12. 12 4 is 48, remaining 2, 4 5 is 20. Right, like per 1 unit weight find out. Per 1 unit weight who is better? This one. Next better? This one. Next better? This one. You know very well. Let me do like that. 3 objects, x1, x2. I am doing the greedy technique. Greedy technique means shortcut. What is the shortcut? Per 1 unit weight find out. Whoever is better one, take him first. Okay, first object having per 1 unit weight more, right? More profit. I will take him. Taking the first one means how much required? 8. How much you have? Actually 10. 10 you have. If you take 8, remaining is what? 2. Remaining 2. Right? With the 2, can I take the second object? Second object take required 6. But I have only 2. Fractions not allowed. I cannot take. Can I take third one? Third one taking 4 required. But I have 2. Fractions not allowed. What is the answer? 0, 0. According to greedy technique, first one you take because of he is giving maximum profit. 8 units over, remaining 2. With the 2, second one I cannot take, third one I cannot take because fractions not allowed. So finally 1, 0, 0. Right? Can you help me now? According to greedy, what is the answer? Only first one is allowed. How much? 120. According to greedy, to this problem, answer is 120, but actual answer is 130. Best answer is 130. Greedy is giving 120, which is the wrong answer. That is the reason. See this one. 0 by 1 knapsack problem. Greedy cannot solve. Shortcut, greedy cannot solve, in fact shortcut cannot solve. So we have to go to dynamic programming, which will cover all possibility. Everyone know dynamic programming, this is the brute force. Everyone know dynamic programming, brute force until 97% same, right? Dynamic programming also will do same story. Dynamic program will cover every possibility, brute force also will cover every possibility. Both will give correct answer. What is the difference? Brute force method, every sub problem, if it is repeating, will do again and again, but dynamic programming will do only one time. This is the only difference. So what I want to say, 0 by 1 knapsack problem, greedy will give wrong answer. That is the reason we are going to dynamic programming. Please be careful. Because of greedy is giving wrong answer. Let me write now. 0 by 1 knapsack. Using greedy will give wrong answer. Means sometimes maybe. See, one place fail only. See this one. To this problem, greedy is giving 120, but actual answer is 130. Let's see this one. 0 by 1 knapsack problem using greedy will give wrong answer. One time wrong only. 0 by 1 knapsack problem using greedy will give wrong answer. So, greedy is giving wrong answer. What is the meaning? Shortcut not there. So, we are going to dynamic programming. So, we are going to dynamic programming, which will cover all possibilities. Which will cover all possibilities. Right, fine, which will cover all possibilities. I am thinking that you are absolutely fine. Now I am starting. To this problem, I have to apply dynamic programming. Please be careful. I am reading once again. 0 by 1 knapsack problem using greedy will give wrong answer. So we are going to dynamic programming, which will cover all possibilities. Dynamic programming is not shortcut, covering all possibilities. How it will be done? You know problem very well. So I am starting now. It is very simple. Please listen. It is very simple. See, make sure that everyone listen. Right? So when you say dynamic programming, see this one. When you say dynamic programming, it is almost like brute force method, which is nothing but a recursive program. I am repeating once again. Right? Dynamic program, everyone know dynamic programming until 97% or 95% it is a brute force only. And one more, we are writing recursive program. Recursive program means, right, a function calling that itself. Let me define to which you want to write the right recursive program. Let me write now. So let's see this one. When you say dynamic programming, so recursive program, a function calling that itself. First define what is the function. Let me define. See this one. Carefully listen. 0 by 1 knapsack. I have to give one name I am giving because I want to write recursive program. So I should give the recursive program name I am giving. See this one. Any name is okay. 0 by 1 knapsack of m comma n is equal to. You want to write the dynamic programming program. First of all, it is a brute force method kind of thing because covering all possibilities. I want to write recursive program also. So I should give the one function name, right? Let me write 0 by 1 knapsack of m comma n. Every time when you say dynamic programming, recursive program, please give one function name first. In the previous problem LCS, before that Fibonacci, here also 0 by 1 knapsack of m comma n. See what is the meaning? The maximum profit we will get. The maximum profit we will get. The maximum profit we will get in 0 by 1 knapsack problem, where capacity of the knapsack, is m and number of objects are n. 0 by 1 knapsack of m comma n is equal to the maximum profit we will get in 0 by 1 knapsack problem, where capacity of the knapsack is m and the number of objects are n. Right? This is when you want to write the dynamic programming algorithm, which is the recursive program, first of all, to that recursive program I have to give name. I given name, I defined also what is the meaning. What is the meaning of this program? What this program will do, I defined. Because I have to write recursive program. I am thinking that you are okay with this one, right? Listen now. So this is the function name. See, 0 by 1 knapsack of m comma n is nothing but the maximum profit we will get in 0 by 1 knapsack problem, where capacity of the knapsack is m and number of objects are n, right? Just give the name without giving the name. See, total problem, keep one name first, right? I'm thinking that everything is fine about the knapsack problem. Let's see the next story. See, this one very simple. Just let's see the next story. See the next story now. One example. You may not get what happened. See this one. When you say dynamic programming, okay, recursive program. So I have to give one name I given. See, exactly total knapsack problem. I kept it with one name. So I am giving one example. See the example. N is equal to 5. Capacity of the knapsack m is equal to, I will give that also. Objects. Profit. Here no shortcut, nothing there. Next one, weights. Object 1, object 2, object 3, object 4, object 5. Next one, profit. Some numbers we can give. 50, 60, 45, 65, 35. Some numbers. Weights. 7, 5, 10, 8, 3. Next one, weights are these, right? Profits are these. Let's see the total weight. 7, 5, 12, 22, 30, 33, right? Total sum is 33. Total sum is 33. Please be careful. Capacity of the knapsack should be less than that. Assume that 25, some number. Number of objects are 5. Capacity of the knapsack is 25. Objects are object 1, object 2 and so on, object 5. Profits 50, 60, 45, 65, 35. Weight 7, 5, 10, 8, 3. Right, I am thinking that you are okay. I am starting to this problem, right? So that recursive program I will apply, right? That recursive program I will apply. Can you help me one small line now? What is the meaning of this one? 0 by 1 knapsack of m comma n. See this one. 0 by 1 knapsack of m comma n. What is the m here? What is the m here? 25. 25. What is the n here? 5. So the meaning is going to be, what is the maximum profit you will get in 0 by 1 knapsack problem, where capacity of the knapsack is 25, number of objects are 5. What is the maximum profit you will get? That is the thing what they are asking, right? It is almost like brute force only. Now see this one. What is the maximum profit you will get in this one, where capacity is going to be 25, number of objects are 5, it's okay. Can you help me now, right? Can I start from left side or right side? Can I say number of objects how many? 5. What is the capacity of the knapsack? 25. That is okay, right? Can I start these objects from left side or right side? Any side, because anyhow you will cover all objects. Anyhow you will cover all the objects, right? Please be careful. Anyhow you will cover all the objects, that is fine, right? Now let me check one interesting answer. You have the objects 5, capacity is 25. To this problem, what is the maximum profit you will get? I can start from left also, I can start from right also, because I can cover all possibilities. Dynamic programming is covering all possibilities, right? That is the reason you start from any side. Can you help me now? What is the meaning of this line? Carefully listen. What is the meaning? See this one. See the meaning. 0 by 1 knapsack of m comma n. 0 by 1 knapsack of m comma n. See this one. M is what for this problem? For this problem m 25. What is the number of objects? 5. See this one. The meaning of this one is going to be, what is the maximum profit you will get in 0 by 1 knapsack problem, where capacity is 25 and number of objects are 5, you are at the 5th object. Number of objects 5, that is okay, you are at the 5th object. If you want, you can start from that side also. Capacity of the knapsack is 25, number of objects are 5, you are at the 5th object. You are at the 5th object. Now can you help me one small line? What is the answer? I am at the 5th object. That is fine. What is the answer for this? We will see now. You only say when this problem termination condition. See the termination condition. It is very simple. One time you listen. It is very simple. 0 by 1 knapsack of m comma n. You only say 0 by 1 knapsack of m comma n. What is the maximum profit you will get in 0 by 1 knapsack, where capacity of the knapsack is m, number of objects are n. What is the profit? See this one. Capacity of the knapsack m, number of objects 5. You only say capacity of the knapsack is 0, number of objects are 5. What is the meaning? Objects there, but capacity of the knapsack not there. So you will get 0 profit. It is the termination. One more thing, right? Capacity of the knapsack is 10, but number of objects 0. What is the meaning? Capacity there, but objects not there, then also 0. Suppose both not there, then also 0. Knapsack problem termination condition is going to be, right, objects over, then also 0. Capacity over, then also 0. Both over, then also 0. So this is the termination condition. See the answer, right? This is the way. If m is equal to 0 or n is equal to 0, capacity over or objects over, then what the profit you will get? Return 0. That is okay. Else. So you came to, listen, this condition true means, right, capacity over, then also 0 is answer. Objects over, then also 0 is answer. Suppose this is fail. What is the meaning? No one, 0. Can I say which object you are? I am, see, this problem having 5 objects, I am at the 5th object as of now. This problem having 5 objects, I am at the 5th object. It is having 2 meanings. Capacity of the knapsack is 25 as of now. This problem having 5 objects, that is okay. I am at the 5th object. Currently I am at the 5th object. Now let me ask now, right? Is objects are over or capacity over, then return 0. Suppose it is fail. What is the meaning? Indication that no one over. Indication that no one over. Can you help me? No one over means I can verify. See the interesting answer. No one over means I can verify. What I can verify? Let me check. Can you help me one small line now? At which object you are now as of now? 5th object. 5th object you are now. Can you help me now? What is the capacity you have? 25. Can you say 5th object you are? You have the capacity 25. What is the object you have? 3. See this one. I am repeating once again. 5th object you are. 5th object you want 3. You have capacity 25. Can you take? I am at the 5th object who want 3. Right? But I have the capacity 25. Can I take him or not? Yes, you can take. Suppose assume that you are at the 5th object. You have the capacity 25, but this object weight is 30. Can you take? No. So this is the case. See the case here. You came here means no one, 0. But see the interesting thing. If, see the answer. If weight of the nth object, which object you are at here? Nth object. Weight of the nth object is greater than. Weight of the nth object is greater than capacity. Then what is the answer? You cannot take. Can you help me? As of now, at which object you are? Nth object. Nth object weight how much? 30. What is the capacity you have? 25. Can you take? No. See this one. Weight of the nth object is greater than capacity of the knapsack. You cannot take. What is the meaning of you cannot take? This is the answer. Return. See the answer. Return. 0 by 1 knapsack of m comma n minus 1. You are unable to take. Simply say, sorry, I cannot take. Can you help me now? Can you help me now? At which object you are? 5th object. What is the capacity you have? 25. Let's ask. Is any one 0? No. Next one. What is the weight of the 5th object? 30. Is greater than capacity? Yes. Then simply say, I cannot take. See this one. One object decrease. M is same. What is the meaning? You are not able to take. Simply say, I cannot take. Then what is the answer? This will becomes now 25 comma 4. It is the recursion. Again same. Any one 0? No. Next one. What is the weight of the 4th object? 8. What is the capacity of the knapsack? 25. Can you take? Yes. Right? Means this is fail. Suppose it is 80. What is the answer? This also you cannot take. Again same. M comma n minus 1. It will become 25 comma 3. It will continue like this. Assume that it is also not able to take. So 25 comma 2. 50. 25 comma 1. 70. 25 comma 0. Any one 0. Return 0. So to this problem, answer is going to be 0 because no one you can take. First of all, 25 comma 5, capacity is more than knapsack, you cannot take. 25 comma 4, continue until this condition. So return 0. So like that. Else, what is the meaning? You only say else, what is the meaning? Any one 0, no. Weight of the nth object is 30. Right, is more than capacity. Yes, this is the story. Suppose this is fail. What is the meaning? Else. Indication that I am at the 5th object. Carefully listen. Capacity of the knapsack is 25. I am at the 5th object. Yes. Right. Let me ask now. Any one 0? No. What is the weight of this one? What is the weight of the 5th object? 30. Is it more than capacity? Yes, this is. Suppose assume that it is not 30. It is the 3. It is the 3. It is the 0. Sorry. It is 8. It is the 10. It is the 5, it is 70. Assume that this is the thing. Then what is the answer? 25 comma 5. Let me ask. Any one 0? No. What is the weight of the 5th object? 3. 3 is more than capacity? No. What does it mean? You came else part. You came else part indication that, right? This problem having some capacity, some objects. Now, whichever object I am, I can take. See this one, whichever object I am, I can take. Can you help me now? Which object you are? Fifth object. How much you want? 3. How much capacity you have? 25. Can you take or not? Yes, you can take, it's okay. Listen, you can take, it's okay. But the problem is what? I can take, but I don't know whether by taking this one I will get a maximum profit or not, or without taking I will get a maximum profit or not. I can take. But what is the dilemma I have? I can take, but it will give maximum profit or not, I don't know. Some people are asking, sir, if you take this one, you will get the profit of 35. If you take this one, you will lose 3, but you will get 25. Right? But one thing, I will get 25, right? I will lose 3, but who knows that for the same 3, someone may give better answer. I can take, but the dilemma what I have is, but is it profitable or not, I don't know. Some people are asking, sir, you can take, it's fine. Is it profitable or not if you don't know? Per 1 unit weight you find out, right? Do accordingly. I done that already. See, greedy technique is that only. I am at fifth object. Fifth object I can take also. I am in dilemma, can I take or not? Because is it profitable or not, I don't know. Sometimes what happened is, if you don't take this one, in future you can take someone else with the same weight. You may get a maximum profit. Sometimes what happened is, if you take now, further you cannot take someone. If you don't take, further maybe you can take someone. We don't know what is going to be happening in future. I can take, but I am in dilemma. Is it profitable or not, I don't know. So it is something like this one. It is something like this one. You have 1 lakh rupee to buy a particular cell phone, right? 80,000 required. You have 1 lakh, right? You went to one electronic showroom. You are asking how much the cell phone cost. They are saying 80,000. You have 1 lakh, right? You can buy, but still you are thinking. What is the reason? You don't know. Is it right? Is it the best one or not? You don't know. Maybe who knows that if you go to the another shop, maybe same cell phone for 70,000 they may give. Who knows that if you go to some other shop, they may give same cell phone for 90,000. So you are in a particular shop, you have 1 lakh, is ready to give for 80,000, you are still in dilemma. What is the reason? Is it profitable or not? You don't know. Maybe next shop will give for 70,000. Maybe next one more shop may give for 90,000. You are in dilemma. You don't know what you have to do. Is it profitable or not? You don't know. Can you help me know what is the answer? What is the dynamic programming? Dynamic programming never take. Dynamic programming never take. Right? If anything dilemma, you will do all. What is the meaning? Nothing there. Whenever you have dilemma, when you come to the sales part, what is the meaning? You can take, you don't know is it profitable or not. Dynamic programming never do guess and all. What it will do is, see this one. I am at the nth object. I can take, is it profitable or not, I don't know. See what he will do. He will do like this one. See the answer. A is equal to, see the answer, A is equal to 0 by 1 knapsack of, see this one, A is equal to 0 by 1 knapsack of m comma n minus 1. What is the meaning? You don't take. You don't take that one without taking that object. Because you may take, see this one, you are at the nth object, you may take, you may not take. You have the chance of taking. Is it profitable or not? I don't know. So what I will do is, without taking, right, without taking that one, right, without taking that one, I will find out what is the profit I will get. Assume that I got A. Next one, with taking. What is the meaning of with taking? 0 by 1 knapsack of m minus wn. Taking means what? That object weight you subtract from m, n minus 1. So here see this one. Here you are not deleting anything from m. Means what does it mean? You are not taking. Because of you are not taking, you will get 0 profit. If you take m, you will lose something, you will get some profit. You are not taken, you didn't get anything. Because of you are taking here, right? You will get some profit of Pn. Whom you are taken? Nth object if you take, nth object weight you subtract from m. Right? So because of you are taken, profit also added. Take, capacity decrease, profit added. Don't take, capacity not deleted, profit also not added. So this is without taking last object. This is by taking last object. I don't know. Taking, not taking, which will give best answer, I don't know. That is the meaning of 0 by 1 knapsack. When you have the chance of taking, you may take, you may not take. Whichever is profitable to me, that one I will do. I don't know which is profitable. That is the reason I am doing both. So what is the answer? C is equal to max of A comma B. C is equal to max of A comma B. So lastly, return C. End of the cells. Right? End of the entire program. So can you help me know what is the first step? Capacity over, then zero profit I will get. Number of objects over, then also zero profit. Suppose using that, both not over. Now what is the meaning? Objects are there and capacity also there. I am at the nth object. Ask the nth object, can I take him or not? He want more weight, I cannot take. Simply say no, I cannot. Suppose this else also fail, I came to this else. What is the meaning? Wherever I am, I can take. Objects there, capacity there, I can take, but I am in dilemma. Is it profitable or not? I don't know. So what will you do? By taking this one, find the answer. Without taking this also, find the answer. But one thing is to see this one, not taking and taking. See, not taking, in both the cases object over. Don't take also object over. Right? Take also object over. But if you take, capacity will be deleted little bit, profit added. If you don't take, capacity will not be subtracted, profit will not be subtracted. Some people are asking, sir, here zero profit, here P of n profit, it is the better? No, it is not better. It is a zero profit, here Pn profit, it's okay, but here still weight there, right? Maybe in future someone else you can take. In future you may not take this. Because of you are taken, capacity lost, but profit added. Because of profit not added and capacity also not deleted. So, because in future maybe better person will come. Right? Here future better person may come, you may not take also. That is the reason. You may take, you may not take. That is the meaning of 0 by 1 knapsack. Right? This is, whenever only one chance, it is something like this one. You went to one of the electronic showroom, you want to buy a cell phone, you have 1 lakh, but cell phone cost is 2 lakh. No chance. Simply they will say, get out. You have 1 lakh, you want to buy a cell phone of 2 lakh, they will simply say no. No other chance. But you have 2 lakh, they are saying 1 lakh. You can buy. Now you are in dilemma. Can I buy or not? Is it profitable or not? Right, like that. So this is the dilemma. See, in dynamic programming, dilemma case, do all the possibilities. You may not take, you may take. That is the meaning of 0 by 1 knapsack. Can you help me now? At this object, you may take, you may not take. 2 choices. At this place, you may take, you may not take. 2 choices. That is the meaning of brute force. Everywhere 2 choices. Right? N objects are there. Everywhere 2 choices. 2 power 5 means 2 power n. That is the meaning of brute force. It is the brute force algorithm. You cannot take one choice. You can take. You may take, you may not take. When you have the chance, you may take, you may not take. Which is beneficial, that one you will do. I don't know which is beneficial. Do both. Take the best one from them. So this is, listen everyone now, this is, right, 0 by 1 knapsack problem. Brute force method is like this. Brute force means what? Covering all. Right? Some people are asking, then what is the meaning of dynamic programming? Until 97% or 95%, both are same. Dynamic programming will cover every possibility. Brute force also will cover every possibility. Right? But here, see this one, but here function call here also function call. In dynamic programming, before calling, just you will do one thing here. What is that? Before calling, you will do one small thing. What is that? Right? Is it there or not in the table? You check. Is it there or not in the table? You check. Is it there or not in the table? You check. Just keep some condition. That is called dynamic programming. This is what is the name? What is the name of this one? It is the brute force. Adding these 3 conditions, that is called dynamic programming. Just let's complete the brute force first. Afterwards, we will go to dynamic programming. Right? Okay. Whatever you got, it's okay. Okay, can you help me one small line now? So this is what is the answer? Brute force method. See, if you want, you can check 0 by 1 knapsack of m comma n. This is the meaning. This is the meaning. So we are going to dynamic programming. First, if you want to go to dynamic programming, first you have to write the brute force. Brute force also cover every possibility. Dynamic also will cover every possibility. Brute force algorithm I written. Now some people are asking, sir, why don't you write the dynamic programming algorithm directly? Why don't you write repetitions there? Then I will go to dynamic programming. Right? Until I will verify repetition is there or not, I may not go to dynamic programming. Without repetitions, if you go, what is the problem with the dynamic programming? Dynamic programming event means compulsory table required. What is the purpose of table? Same person is coming again and again. One time compute, store. You can reuse it. But if you, without repetition, if you go, what is the answer? You will compute and you will store, but it is not coming back again. Space waste. Without repetition, if you go to dynamic programming, what is the problem? You will compute and you will store, but no one asking it. What is the meaning? I think you wasted a lot of space. You are wasted a lot of space, no one repeating, time also not decreased. In the dynamic programming, you are ready to lose some space. What is the reason? Time decreasing. Because of same person coming many times, one time you are doing time saved, but whenever repetition not there, time also will not save, space wasted. Dynamic program is the worst idea. whenever repetition not there. What is the reason? Repetition not there, you are computing, you are storing. Same person not coming back again. What is the meaning? Time not changing, space is increasing. Unnecessary. First be comfortable, is it repetition is there or not? So brute force dynamic programming same until, right, almost 95% in the brute force method keep some conditions like this. In these 3 stars, right, just write the condition, not there, call, not there, call. Like that 3 places you keep, it will become a dynamic program. Okay, whatever you got, it's okay. See this one, until now. To find out knapsack problem, I written the brute force method algorithm. In those stars also, if I fill, it will become dynamic programming, right? Anyhow, let me see one small line. Can you say in this program, which will give best case? I think this. It is the best case. Why best case? 2 else part. It is also else part. Best, see, if part don't give anything, else only. This else part, in this else part, many function calls. Here one function call, best case will come. When the best case will come? Every object I cannot take. This object I cannot take. I think n time. Order of n time. Every object I cannot, because every object weight is more than capacity. Right? Here more function calls. What is the answer? I think this is the place where worst case, average case will come. Right? Here worst case and average case. Write the recurrence relation and solve it. Write the recurrence and one more thing. See this one. And one more thing. See this one. If you observe correctly, 2 function call binary tree is coming. If you observe correctly, 2 function calls binary tree coming, right? And one more binary tree is coming, it's okay. In the first one also n decreasing, in the second one also n decreasing. M may decrease, may not decrease, but n guarantee will decrease. If you want, you can check, right? Binary tree is coming, n level tree coming. Binary tree, n level tree is coming, right? So let me write how to find out time complexity. See this one. See this. See, make sure that everyone listen. T m comma n is equal to, what is the answer? Time of 0 by 1 knapsack of m comma n. T m comma n is equal to time of 0 by 1 knapsack of m comma n. Now see the recurrence relation. Worst case and average case. Same thing like previous problem. See, T m comma n is equal to. So what is the answer? See this one. This one will take how much time? T m comma n minus 1. As it is. This one will take, forget about profit. Time complexity we are talking. Time complex means these recursive calls. Remaining things you don't worry. T. What is the answer? M minus Wn comma n minus 1. This one, see this one. This one. After function calls are over. No loop, nothing. Constant time. Let me write. T m comma n minus 1 plus T m minus Wn comma n minus 1 plus C. Same, whatever way you will find out for the previous problem, same thing, right? And one more, listen, one more, right? 2 function calls every time. 2 function calls every time, binary tree. One more thing, m may decrease, may not decrease, but n always decrease. So if you want, you can check, n level tree will come. N level tree, every first level C, second level 2C. This is the series which going on. How many level tree? N level, 2 power nc. Right? It will go to C into 2 power n. So time complexity of this problem, order of 2 power n. This particular recursive program time complexity, order of 2 power n. Some people are asking, why order of 2 power n came? What is the answer? Because of 2 function called binary tree. Next one, here also n minus 1, here also n minus 1, right? N level tree will come. If anyone having small doubt, take one example and verify. With the help of tree, you verify how many level tree will come, right? It's something like recursive tree method you can do. If you want, I will do that also, don't worry. So n level tree, so stack space, n level. It is a stack space. It is the time complexity without dynamic program. This is brute force method because these conditions I didn't kept. It is the brute force method, time complexity 2 power n, stack space n, right? Please be careful. Some people are asking, sir, how you know how many levels? I done this problem many times. So n level. I given the proof also. 2 function call, here also n minus 1, here also n minus 1, means n always will decrement minus 1, minus 1, minus 1, n level. Here also m decrementing, sometime not. So it may little bit decreasing, something like that, but it is always will decrease. Always. If you see the LCS, right, m minus 1 n, right, next one m comma n minus 1. So one time m decrementing, one time n decrementing, but here always n will decrement. So n level tree will come. If you have small doubt also, one recursive tree you take for this problem, you can verify. Let's check here. Small example. 0 by 1 half sec of m comma n. What is the answer? M 25. N 5. Let's check here. Fifth object. Fifth object. Can I take fifth object? Yes, but I have two choices. When you can take two choices, you may take, you may not take. Can you help me now? If you take, what will happen? If you take from the m, 3 will be deleted. So what is the answer? 22, right? But object is 4. Previously 5 objects, now 4. If you don't, this is what is the answer? If you take, let me write. What is the first function called? If you don't take, let me write. If you don't take, what will happen? 25 comma 4. If you take, taking fifth object means what? What is the answer? 22 comma 4. See, whether you take or not, number of objects will decrease. Similar way, this also. What is the answer? 25 comma 4. Fourth object. Fourth object, can you take or not? Yes, two choices. You may take, you may not take. If you don't take, 25 comma 3. Right? If you take, what is the answer? 8 subtract. From the 25, subtract 8. What is the answer? 17 comma 3. Again same. Third object. Third object taking how much required? 10. Right? I think you have 25. Yes, you can take. You may take, you may not take. 25 comma 2. If you take, 15 comma 2. Same way here. 25 comma 2. Second object. 5 required. Yes, I can take. I may take, I may not take. What is this? 25 comma 1. This is 25 comma, sorry. What is this one? 20 comma 1. Same way. First object. What is the answer? First object taking required 7. I have 25. Yes, I can take. I may take, I may not take. 25 comma 0. This one? 18 comma 0. So, if you want, you can check how many level? 5, 4, 3, 2, 1, 0. Actually, n plus 1, approximately n levels. Actually, n plus 1, approximately n levels. So, that is the reason. So, because of I done many times, I got to know 0 by 1 abstract problem, right, on n objects. It will take n level tree, n level binary tree. This also, if you want, you can expand. N level binary tree came like this. So, this recurrence relation, if you solve using recursive tree method, you got to know n level, actually n plus 1 level. If you want, you can write. Stack space is n plus 1. So, if you add all of them, time complexity becomes 2 power n. And one more, see this one. One more, carefully listen. Carefully, this also. Can you help me? What is the purpose of this tree? There are two purposes. One is knowing the number of levels. One more, repetition there or not. Can you check until now is there any repetition? No. Let me check further. Repetition is there or not? That is the reason. Few more levels you draw. Actually, to know height, leftmost path, rightmost path enough. If you want to know repetition is there or not, few more things we expand. What is the 22 comma 4? Fourth object. Fourth object, it required, I have 22. Yes, I can take. Two choices. What is the answer? You may not take. 22 comma 3. You may take. 8 subtract. What is the answer? 14. 14 comma 3. Again, same thing. Right? Rightmost one, let me expand. What is the third object? Third object required 3. Sorry, third object required 10. I may take, I may not take. So, what is the answer? If you don't take, 14 comma 2. If you take, 4 comma 2. Same thing here. What is the answer? Second object. Second object taking required how much? Second object taking required how much? 5, but I have 4. So, I cannot take, only one choice. So, what is the answer? I cannot take means 4 comma 1. First object taking how much required? 7, I have 4, I cannot take. So, what is the answer? 4 comma 0. So, you can stop it. See, until now no repetition. Until now no repetition. Please be careful. So can you help in why are you drawing the tree? Two reasons. One is knowing the height. Height you know already. How many? N levels. So this is the story. Next one more purpose of this tree. What is that one? Repetition is there or not? Repetition is there or not? Please check here. I drawn the diagram. See, actually I don't want to write middle part, but still I written. Why? Repetition is there or not? See this one. Repetition is there or not? See this one. I think 7, 1. 7, 1. Some repetitions are there. 12, 1. 12, 1. Some repetitions are there. Right? Repetitions are there. Let me write. In the above recursive tree. In the above recursive tree, some function calls are repeating. Some function calls repeating. So, we will go to dynamic programming. In the above recursive tree, if you want to have a recursive tree. In the above recursive tree, this is a recursive tree. Some function calls are repeating. So we will go to dynamic programming, which will solve distinct function call. Which will solve distinct function calls. Right? Next one, you know very well. What is the next one? See the question here. How many distinct function calls in 0 by 1 knapsack of m comma n? How many distinct function calls in 0 by 1 knapsack of m comma n? You know, dynamic programming is distinct function call. See the answer. See the answer now. 0 by 1 knapsack of m comma n. Assume that m25, n5. Assume. Answer 0 by 1 knapsack of m comma n, m25, n5. So what is the answer? If you see, whenever this algorithm is going on, n always decrementing by 1 until 0. What is the answer? N plus 1. Next one, right? M also decrementing based on the right capacity of the based on the object weight. M also decrementing, right, based on the object weight. So worst case what can happen? Object weight is keep on changing, right? Worst case what happened? Assume that this also decrementing by 1. Upper bound I am giving. It will goes to right m plus 1. How many distinct function call in 0 by 1 knapsack of m comma n? Answer is going to be 0 by 1 knapsack of m comma n. Right? N will decrement. Right? N will decrement by 1, n plus 1 time. M also decrementing by object weight. Right? Because of object weight keep on changing, upper bound. Right? So I think minus 1 like that, m plus 1. So if you see total m, right, m plus 1 ways, n plus 1 ways, at a time both combinedly m plus 1 into n plus 1 distinct function calls. These many distinct function calls, right, which will goes to right mn distinct function calls. So finally mn into right every function call will take constant time. See the program if you want. Order of mn. This is using dynamic programming. Dynamic programming, right, time complexity this. Time using dynamic programming, right, worst case and average case. Best case you know already there. Right, see time complexity using dynamic programming, worst case, average case. What is the best case? You know very well. What is the best case? If you remember, order of n, best case. Right, and one more thing I want to ask you. Right, what will be the right mn distinct function call? So what is the answer? Let me check here. Extra space. Extra space. Because of dynamic programming, it is a recursive program. So stack required, table required. Can you help in what is the stack? Can you help in what is the stack? What is the stack size? What is the answer? N level tree, n. What is the table? I think mn distinct function calls, mn. So finally order of mn. Order of mn. So this is using dynamic programming. Dynamic programming extra space is this much. Dynamic programming time is this much. Next one, without dynamic programming, before tree, it is a dynamic programming. See this one. This side maybe I written. Without dynamic programming, this is the story. No distinct function calls, nothing. right? This is the right initial part of the dynamic programming, but those stars also filled that then fully dynamic programming. Until now it is a brute force. To this brute force, time complexity 2 power n, stack space, right? Until now table not there, stack space n. With dynamic programming, see what the further story. Above many function calls are repeating, we will go to dynamic programming. Distinct function calls are mn, that is the time complexity, right? So stack space is going to be, sorry, extra space is stack and table mn. Fine, I am thinking that you are absolutely fine. So with dynamic programming, time is order of mn, without dynamic programming time is 2 power n. Space is, right, stack extra space there n, here extra space mn, space little bit increased, time decreased a lot. So what I want to say indirectly, directly, right, in the dynamic programming all problems are similar, almost similar story. Somewhere dilemma will come. Can you say where is the dilemma in this? Right, there is an object you can take. What is the dilemma? You may take, you may not take. In LCS, what is the dilemma? Whenever no matching there, right, you may decrement first one, you may decrement second one. In the Fibonacci, what is the dilemma? In the Fibonacci, no dilemma. Fibonacci of n minus 1, Fibonacci of n minus 2. So first problem Fibonacci, because of you know very well, that is the reason I took that as very simple. Whenever recursion is going on, some function calls are repeating, right, just write one time. First time compute and store table. Indirectly, directly all are having similar story. Please go through it once. Right, I am thinking that you are absolutely fine. Right, now let us see this one. See carefully, one very very important point coming. One small suggestion also can help you know. Why are you going to the dynamic programming? See, in the above recursive tree, some function calls are repeating, we are going to dynamic programming. It's okay. Can you see in this particular tree, is there any repetition? Yes, repetition. Repetition is there, but very less or not? Repetitions are there, but very less. Everyone know. In this tree, repetition is there, not many, but in the previous problems, if you observe, many repetition, here very less repetition. So try to remember. In 0 by 1 knapsack problem, if you observe, repetitions are very less. Repetitions are there, but very less, right? Now can you help me one small line now? Can you help one small line? Using dynamic programming is a distinct function call. Using dynamic programming, right, distinct function calls how many? Mn. So time complexity of the, see this one, time complexity of 0 by 1 knapsack using dynamic programming, order of mn time complexity or not? Now listen. Carefully listen this. See this one. In 0 by 1 knapsack, it is a note. So if anyone unable to see, just roughly I written. See the note, in 0 by 1 knapsack of m comma n, very less repetitions are there. So time complexity of 0 by 1 knapsack of m comma n using dynamic programming, order of mn approximately equal to order of 2 power n. Because of that reason, 0 by 1 knapsack of m comma n is NP complete. If anyone asks you why it is NPC, say this reason. If time using dynamic programming, this best case is this, right? So extra space, stack and table, how many distinct function call? That much, right? Next one more. Because of repetition is there, I went, but I got to know very less repetitions. Anyhow, repetitions are there, very less repetition. Next one. In this tree n level, so if you solve this reference relation, n level tree, n level, right, will come. One series will come if you solve. Time complexity order of 2 power n. All three will be similar. Please be careful. Previous problem, this problem similar. Yeah. So next application is sum of subsets problem. Sum of subsets problem, right? This problem and previous problem almost similar, right? Just see one time. What is the problem? Read the problem. Input. Set of n distinct positive integers and integer m. What is the input? Set of n distinct. See, at least follow this. I am really saying to you, if any problem is not okay, try to concentrate on the next problem. Right? Out of these 4 problems, one is okay, remaining all are okay. Right? Let me read the sum of subsets problem. What is the meaning? See this one. Input. Set of n distinct positive integers and integer m. N integers and one more integer m. Right? Totally n plus 1 people. What is the output? Find any subset. See this one. Set of, let me write this. Input is going to be set of n distinct positive integers. Set of n distinct positive integer and integer m. Output is going to be find any subset of given set. such that sum is m. What is the meaning? Right? From this given set, find any subset whose sum is 250. That is the meaning of sum of subsets problem. From the given set, find any subset so that their sum becomes 250. Can you find out one subset whose sum is 250? Find out one subset whose sum is 250. Maybe many there. He is asking find any subset of given set such that sum is m. So what is the answer? Find any subset whose sum is m. So what is the answer? If you observe clearly, right? Say this may be the case. Check correctly. 30 plus 70, 100, 100 plus 100, 200 plus 50, 250. There may be so many ways. It is one of the way. Can you help? 25 plus 15, how much? How much it is? I think it is going to be 40. 40 plus 40, 80 plus 20, 100. This is 100. This is also 150. There may be many other ways. So what is the one answer? One answer is this one. 70, 50, 30, 100. This is the one way. What is the one more way? Right? 50, 100, 15, 25, 20, 40. It is the 40 plus 20. It is going to be 100, 150. This is one more answer. Find any subset whose sum is 250. Of course, right? This is the way. Right? I'm thinking that you are really fine. Some students are asking, sir, how to solve this problem? Right? Try to remember how to solve this problem is you don't know subset size also. Find any subset whose sum is m. Because of you don't know what is the subset size also, the answer for this one is going to be brute force method. What is that? Find all subsets. Find one length subset. Right? Check. Find one length subset. Is there any sum? Right? Is going to be 250. No. Find two length subsets also. Please check. Find 3 length subsets also, find 4 length also. Like that you know very well for the given set 2 power n subsets are there. All the subsets you have to check. Right? So every subset checking constant time is in that like the 2 power n times. So time complexity becomes 2 power n. Time complexity becomes 2 power n. Right? So that is the brute force method. While doing that some sub problems may repeat. Do one time only. That is called dynamic programming. What is the brute force method? Cover all subsets. Cover all subsets, right? That is the brute force method. So let's see rough diagram. How to solve this problem? Roughly I am giving, right? Please listen properly. Roughly I am giving. See the answer? What is the problem name? Sum of subset. If you want to write the brute force method, right? Using recursion, one function name you have to give. Let me give roughly function name. Careful listen. Everything is same from now on. This problem I clearly explained to you. Now how to solve this problem? Let me write the brute force algorithm using recursion. If you want to do that, one function name you have to give. I am giving. See the rough diagram. See the rough diagram. Sum of subsets of m comma n. What is the meaning? Let me write. Sum of subsets of m comma n is nothing but, right? See m comma n is nothing but finding. Let me read. Listen everyone. If you want to solve this problem using dynamic programming, first I have to write brute force recursive program. If I want to do that, I have to give one function name for our problem. I am giving SOS of m comma n is equal to finding any subset from the given set of n elements such that its sum is m. I am repeating once again. SOS of m comma n is equal to finding any subset from the given set of n elements such that its sum is m. You have to give one function name. Yes, I given. Yes, I given. Now see the answer. Because of I given, please carefully listen. Please carefully listen. So I am giving the answer. Please see this one. Initially, I didn't take one element also into subset. Assume that subset is initially pi. Assume. Initially, subset is pi. Assume that. I am writing the program very simple. Initially, assume that subset is pi. What is the meaning? One element of subset. If you want, I will write subset. SS means subset. SOS of m comma n means, right? Means finding a subset in the given array of n element, right? So that its subset sum is m. That is the goal. So for that purpose, I am checking that I am initially assigning, right? So subset is equal to pi means I am not taken one element also. When I started, carefully listen. When I started, right? So if n0, what is the meaning? Array is over. If array is over, from where I will take subset? It is not possible. Simply say, right? Return -1 means not possible. It is not possible. Return -1 saying that some error message enter. Let me write termination. Let me write. If m0, what is the meaning? m0, you want subset sum as 0. If you want subset sum as 0, return ss. Return ss. Ss is initially pi. That is answer. Suppose assume that m is 0. This is the case. Suppose assume that if n0, m not 0 but n0, then what is the answer? Return -1 saying that not possible. Return -1 or return error saying that not possible. Right? This is the termination. SOS problem of m comma n means in the given array of n elements finding a subset whose sum is m. Right? That is the goal. Before starting, subset what you are selected until now is pi. Now ask, is m 0? You want subset sum as 0? Yes. Yes. Then right, don't take any one. Return SS. Suppose that this is fail. n0 ask, m is 0 fail, but n0, what do you mean? No element is there. If no element is there, from where I will take subset sum, right? Return error, something like that. Now come to the major story, else. Can you help me now? Else, what is the meaning? No 1, 0. See this one, no 1, 0. Can you help me one small, think about this problem? No 1, 0. Think about this problem. How many elements are there? 8 elements are there. Carefully listen. It is very simple problem. Right? So, subset sum I want 250, subset sum I want 250, next one, array contain 8 elements. I want to solve this problem. Subset sum I want 250, array contain 8 elements is equal to, initially SS is pi, see the answer, m0, is m0, you want subset sum as 0, no. Is the number of elements are 0? No. Now I am at else. See the answer. When you are at else part, indication that no 1, 0. Can you help me now? No 1, 0, it's okay. You want subset sum as 250. Right? This array contain 8 elements. Right? In this array, you want to find out a subset whose sum is 250. Everything fine. Now can you help me now? In this array, from where you will start? Recursive call you will start from array contain 8 elements, subset sum as 250. From where you will start? You can start from anywhere. You can start from here also. What is the meaning? Array contain 8 elements. You want subset sum as 250. You are at the 8th element here. You are at the 8th element. As of now, you are at the 8th element. If you want, you can come from that side also. You are at the first element. That is also okay. SOS of m comma n is nothing but you want subset sum as 250. And array contain 8 element, in that you are at the 8th element. Can you help me now? You are at the 8th element, you want subset sum as 250. Can you help me one small line now? Please listen, please listen. Wherever you are 8th element, right? That element is 40, that element is 40, but how much you want? 250. Can I take him? Yes, there may be a chance. See this one. By taking this one, you may get answer sometime. Right? Is it right or not? Suppose isn't that subset sum you want 250. You are at the 8th element, 8th element itself is 400. Can you take? No. I am, see this one, array contain 8 elements. As of now, I am at the 8th element. I want subset sum as 250, right? So, it is 400, but I want only 250. Can I take him? No. So, same story. What is the answer? This line. See the line? If, what is the name of the set given? Yes. See this one. If S of n is greater than m. What is the meaning? In the set nth element, wherever you are, that nth element is greater than m. You want subset sum as 250, but nth element itself is 400. Means I think you cannot take. So what is the answer? Return. See this one, return. What is the answer? Sum of subsets of. What is the answer? M comma n minus 1. Simply don't take. I am at the nth element whose value is 400, but I want subset sum as 250. It is not possible at all. Don't take. Else, what is the meaning? I am at the nth element, right? That is greater than subset sum. Fail. What is the meaning? It is not greater than, it is less than. It is not greater than, it is less than. Right? See this one. I am at the 8th element, that value is 40, but I want subset sum as 250. Can I take? Yes. Because it is only 40, you want 250. By adding this one to subset, you may get. So what is the answer? I think you can take, but one thing is true. By taking 40, always you may not get C. Without 40 also possible. With 40 also may be possible. So I can take, but I am not guaranteed that it should be there in my subset. It may be there, may not be there. So that is the answer. So see this one. Else. See the answer. Else. What is the answer? You have to do else like this one. SOS of. What is the answer? SOS of m minus S of n. Right? from m subtract and n minus 1, and one more, from m delete that element, from m delete that element, right? Next one, number of elements previously 8, now it became 7, right? Now previously you want sum as 250, now 250 minus 40, what is the answer? 210. But one thing, because of you are taken that nth element, right, to ss add it, ss is equal to ss union s of n. When you take any element, from m delete, number of elements becomes n minus 1, because of you taken in the subset add it, right? Next one, see the next one, this is if you take, if you don't take SOS of m comma n minus 1, because of you are not taken, from m you are not deleting, right? For the SS you are not adding. See this one, when you take element from m delete, right, for the SS you add. When you don't take, from m don't delete, SS don't add. So this is the answer. When you can take, you may take, you may not take. In these two people, who is the answer? Who will make m value 0? That will be the answer. Supposition that I am doing this one, m value 0, then this will be the answer. If not, this will be the answer. Whoever make m value 0, that time whatever s is there, ss is there, please return. Right? Like this. Whichever make ss as the, right, whichever make m as 0, that will be the answer. Roughly I written the program. Please be careful. Now see the one small thing I want to say to you, just listen this also. Can help you now. See this answer carefully. Those people who are having small doubt also, see this answer carefully. M is 250 I want, right? This is the one. Can you help you now? Every element, what are the choices? 2 choices. You may take, you may not take. 2 choices. Taking also one path there, not taking also one path. See this one, I am not taking. Next element. So taking also one path, not taking also. I am talking about this answer. I am not taking this. Next. This also again 2 choices. You may take, you may not take. I am not taking this. This also 2 choices. You may take, you may not take. This choice, this also. You may take, you may not take. This one. You may take, you may not take. Assume that I am taking. Then what is the answer? What is the meaning of taking? You only say. From m 250, this 100 is subtracted. How much? 150. But one thing. For SS, right? This 100 is added. Next one. What is the next one? This is completed. This one. I am at here. Right? You may take, you may not take. Yes, I will take. What is the answer? 150 minus 30. What is the answer? 120. Because of you are taken. 30 also added. Next again same recursive call. Right? You may take, you may not take. If you take. So what is the answer? 120 comma 50, which is going to be 70. Right? I think 50 added. That is also. Next one. You may take, you may not take. If you take, what is the answer? 70 minus 70. What is the answer? 0. What is the answer? 70 added. So for this one, see, many paths are there. Everywhere 2 choices. I am talking about this path where this answer will come. Right? Can you help me? In this path going. See this one. Somewhere m value 0 came. Somewhere m value 0 came. At that time return SS. A will come. Everywhere 2 choices. See, I took only one path. 2 power n paths are there. Right? In which path m value becomes 0, that will be the answer. So m value 0 means what? By subtracting few numbers from m, finally became 0. What is the meaning? The numbers which you subtracted, if you add all of them, m value becomes 250. This is one path, right? So 2 power n paths are there. Some people are asking, sir, how 2 power n paths? 2 power n paths. See, this may be the case. See this one. This is case. I want to find out 250, right, in the array of 8 elements. So what is the answer? You may take, you may not take. This choice I am talking. You may take, you may not take. Let me ask you one small line. So what are the positions here? 1, 2, 3, 4. Right? See this one. This is the 8th element. 250 sum you want, you are at the 8th element. You may take, you may not take. Suppose taking is this, not taking is. What is the answer? If you don't take, 250 comma 7. Again 7th element. You may take, you may not take. What is the answer? 250 comma 6. Next one, it is also same. You may take, you may not take. So what is the answer? Right? 250 comma 5. You may take, you may not take. Now see the answer. 5th element. You may take, you may not take. If you don't take, 250 comma 4. From here onwards, game will start. See, this is the one path I am talking. Like the 2 power n paths are there. This path only I am talking. Can you help me now? 250 comma 4. You may take, you may not take. If you take, what is the answer? If you take, 4th element is 100. If you take, what is the answer? 100 comma 3. If you don't take, 250 comma 3. Next one. Again here, you may take, you may not take. 3rd elements, if you take, what is the answer? 30. right? I think 250, if you remove the, how much, 100, it will become 150. 150. Next one, 150 comma 3, what is the answer? 30. If you delete 30, what is the answer? It is the 120 comma 2, this is 150 comma 2. Next one, same, second element, you may take, you may not take. What is the second element? Second element, see there, 50. So this will become 70 comma 1, if you take, if you don't take, 120 comma 1. Next one, same thing here. What is the answer? First element, you may take, you may not take, 70. So what is the answer? 0 comma 0, one more, 70 comma 0. See this one, whenever m value 0, see this one, recursion, whenever m value 0, right, return SS. What is the answer? See, this path only will return, not total tree. Total tree contain 2 power n possibilities. Return this path only, this path having 1 SS. Those all will be written, right? Those all will be written. Please be careful. This path only will return, right? Like this. Whenever this one, in whichever path m value 0, that will be written. So what is this one here? 70 you are taken. Right? Next one, 70 you are taken. What is the answer? One more thing, right? 120 becomes every element. See, this element, what is this side indicate? You are taken 70. What does this side indicate? You are taken second element. See, you are taken first element. Left means taken. You are taken first element. You are taken second element. You are taken third element. You are taken fourth element also. Next one, you are not taken fifth element. You are not taken sixth element, like that. 2 power n paths are there. Which path leads to m value 0? That will be the answer, right? 2 power n paths are there. Same thing here. See this one. This will give taking. This will give not taking. Like that, one tree. Everyone having 2 choices like this. Taking, not taking. Like that, right? In whichever path, right? Assume that I am continuing like this. One of the path. So this path, wherever m value 0, that path I will return like this. So every path having 1 SS, it will be written. Suppose this path m value not 0, n 0, error, leave it. And one more, this path m is not 0, n 0, error, leave it. Suppose this path m 0, then this path will be written. Right? Error means continue next one. I am not writing the total algorithm. I written our required part. See this one, when I am going this path, m value 0, right? I think you got the answer. M value 0 means you got the answer. Return that answer while coming back. In every path, one element you subtracted. Those all are added to SS. They will be written. See, I am at the nth element. Nth element value is more than sum. You cannot take, leave it. Suppose when you can take 2 choices, you may take, you may not take. You may take, you may not take. Right? If not possible, don't take. If possible, you may take, you may not take. When you say everywhere 2 choices, you take, you don't take, binary tree will come. 2 power n choices. One of the path m value 0, return SS. Right? M value 0, some point of time m value 0 will happen, return SS. Do this also. Continue. Whenever m0, at that time what is the SS to that path, it will be written. It will be written. And one more thing I want to ask you, see this one. One more thing I want to ask you, if you want, you can observe. Whatever you got, it's okay. Whatever you got, it's okay. One thing I want to say to you, listen correctly. Listen correctly this line. If you see 0 by 1 knapsack problem, and this problem if you observe, right? Forget about if condition. If condition is termination. 0 by 1 knapsack problem, this problem if you observe, right? See, this part is same. This part also same. Please check. Small things you leave. See, I am at the nth element. I cannot take, leave. I can take. You may take, you may not take. This is exact like 0 by 1 knapsack. Same story will repeat. Same story. 0 by 1 knapsack, whatever happened, this also same. Just I want to give rough diagram, I written this. Sum of subsets problem, 0 by 1 knapsack problem, same. Terminology only will change. There also see this one, from the capacity of the M, you are deleting, right? There profit will be added, here subset will be added. Whatever element you deleted, previously profit added in the 0 by 1 knapsack, but here subset added. Union will be done, their profit will be added. I think if possible, I will show that algorithm. See, same algorithm. Same, see. Not possible, don't take. Possible, you may take, you may not take. This one. Don't take, take. In the case of 0 by 1 knapsack, taking means what? Profit added. Their taking means subset will be union. Both exactly same. Sum of subset, this one. See the only else part. If part not required, if cannot increase time, cannot decrease time. Problem to problem, small changes. This is also constant time, this is also constant. Major thing is these only. So if you want, you can check. Sum of subset problem 0 by 1 knapsack problem, else part is same. Please be careful, exactly same thing. So what I want to say indirectly, directly, right? This one and 0 by 1 knapsack same, just I am giving a rough diagram. Please see this one. Same thing as it is, without dynamic programming. Without dynamic programming, it is with dynamic programming. Right? Let me write this. Whatever you know, both are same. I want to say that both are same. See, without dynamic programming, what is the time? Please check. Both will be same, 2 power n. What is the stack space? Verify yourself, both are same, n level stack. Come to the with dynamic programming. What is the time? Time, I think you know very well, mn, distinct function calls, mn. What is the extra space? What is the answer? Stack is going to be n, distinct function calls are mn, total is mn. Total is mn. This with dynamic programming, is without dynamic programming. Right? And one more, if anyone still having some doubt, see this one. If anyone still have some doubt, I want to say to you, this is equal to 0 by 1 knapsack. Both are similar, same algorithm. Please go through the previous algorithm and check. There you are trying for maximum profit. Now here you are trying for subset sum is m. When can I say subset sum is m? From the m you are keep on subtracting, you got 0, means you got subset sum as m. Please be careful. Whenever see this one, some people are asking, sir, here you are not written anything, really not required also, really not required, because whenever recursion is going on, so just complete this, right? It is the recursive call, complete this one and complete this one. When you are continuing, see every time SS adding, whenever it happened, SS will change, whenever it happened, SS will change, right? Whenever you are continuing like this one, somewhere m0. See, from m, I am subtracting, somewhere m becomes 0. What is the meaning? Whatever you subtracted, all are added here, right? If you do total sum, m will come. I done already here, see, one path. 8th element don't take, 7th element don't take, and so on. So, somewhere m got 0. Return SS, see, return this, all will be there. Whatever SS is there in that path, that will be returned. So, finally I want to say to you, if you got 0 by 1 knapsack, you got this only, terminology will be different. And one more thing I want to ask you, using dynamic programming, see this one, using dynamic programming, right? So, what is the time complexity of sum of subsets problem? Order of mn, because of, see this one, because of less repetition, right? Time complexity of sum of subsets problem using dynamic programming, order of mn, right? Approximately equal to order of 2 power n. So, it is NPC problem as it is like previous. Because of less repetitions, time complexity of sum of subsets problem using dynamic programming, order of mn, approximately equal to order of 2 power n. So, it is NPC problem. Now, finally, see those people who are having small doubt, listen. Those people who are having any doubt on this, final note I want to write. See this one, note I want to write. Carefully listen this note. 0 by 1 knapsack is equal to sum of subsets. I want to say that. If I want, actually I want to say directly this line, but you may not know what actually problem and all. So roughly I explained, little bit I explained. Now, those people who is having small doubt also, can you go back once? See this, very simple. Don't make complex story. Very simple. What is sum of subsets problem? I explained first. See, I explained. So, is there any subset whose sum is m? Yes, I given 2 subsets. This subset sum also m. This subset sum also m. Can you help me one small line now? This subset sum is m. What is the meaning? If you add all of them, it will become m. Another way of saying. If you add all of them, it will become m. That is one way. One more way. From m, subtract all, it will become 0. From m, see this one, m is 250. From m, you subtract all these people one by one. Lastly, you got 0. Indication that whatever you subtracted, if you add all, it will become m. So it is indirectly, see this one, it is indirectly nothing but sum of, right? It is indirectly nothing but 0 by 1 knapsack. 0 by 1 knapsack also, from m you are subtracting. Here also from m you are subtracting. But when you subtract from m, right, whenever finally m value becomes 0, whichever you subtracted, that is the answer. Suppose assume that m you are subtracting, m not 0, n 0. What is the meaning? That path is error. What is the meaning? That possibility don't count. 2 power n possibilities. What is the meaning of everywhere 2 possibilities? What is the meaning? Big binary tree. Indication that 2 power n paths will come. Everywhere one path is there. One path is what? Not taking all zeros. One more path, taking all, right? All ones. Remaining possibilities also say. Every possibility you check. Whichever possibility given m0, that possibility you return. Right? So I think I explained, initial few minutes I explained the problem. Yes. After explaining, right? So just I followed the dynamic programming story. What is that? First of all, if I want to write dynamic programming problem, I should write the recursive program, which is the brute force. So I should write the one function, SOS of m comma, finding subset from the given array of n elements such that its sum is m. That is the goal. For that I started. SS is initially pi assume. Now SOS of m comma n, right? If m0, what is the meaning? Subset sum you want 0, then don't take anything, whatever SS is there, return. Suppose m not 0, n 0, what is the meaning? I think elements not there. If elements not there, from where I will get subset sum? Error message. Suppose m not 0, n also not 0. What is the meaning? Some elements are there, right? Some elements are there, some capacity also you want. But you got to know that capacity is more than the, element is more than capacity. You cannot take at all. Suppose element is not more than capacity. What I mean, you can take, right? I don't know by taking or without taking, which will give m as 0, you don't know. Taking means what? From m delete the value. Not taking means what? Nothing to delete. So if you keep on taking, every time is from m something deleted, finally what will happen? Right? This will happen. Right? Finally 0 will come. Then return SS. Right, like that it is there. So whatever you got, it's okay. If anyone get this entire story, well and good. If you don't get, see this one, if you don't get, try to remember this is equal to 0 by 1 knapsack. See the program, exactly same. I shown the program also. This is equal to, right, 0 by 1 knapsack. 0 by 1 knapsack, same story I written. And the 0 by 1 knapsack also I said, what is that one? Because of very less repetition, time complexity of 0 by 1 knapsack using dynamic programming, order of mn approximately equal to 2 power n. So it is also NPC. Final conclusion. See the final conclusion. 0 by 1 knapsack is equal to SOS. Actually, listen, I don't want to say this application. Sum of subsets problem, I don't want to say to you. If I don't say, you may think that, right, complex one I left. No. 0 by 1 knapsack, SOS same. In one of the book they given this also. Right? They first explained the 0 by 1 knapsack. Right? Next they written sum of subsets problem. He explained the problem only. After problem is over, right, they give an answer. Answer is 0 by 1 knapsack, sum of subsets both are equal. Please go through by yourself. But I given at least rough diagram. Right? Rough diagram is enough. You are not a small kid. Rough diagram is enough. And one more, if you observe all the 4 things whatever I explained, every time one function name I am giving. What is the reason? If function name not there, what is the meaning of recursion? Recursion means calling that itself. Right? You have to give one function name. Some people are asking, sir, how to give function name? You know what is the problem? Based on that problem, one function name you create. LCS, you want the length of the longest common subsequence. So LCS of m comma n, length of the longest common subsequence of 2 sequences x and y, where x contain m symbol, y contain n symbol. Similar way, 0 by 1 knapsack means what? So that problem, keep one name. Total problem, whatever you understood, keep one name. So that name call again and again. Dilemma there, do all possibilities. So one big tree will come. Repetition there, go to dynamic programming. Right? Like that you do. So final thing, sum of subsets whether you got or not doesn't matter because it is equal to 0 by 1 knapsack. Terminology only differ. Those people who don't know this, right, they know 0 by 1 knapsack, they will say I don't know sum of subsets. You know one means you know both. Both are NPC problem. Why? Because of less repetition, right? Time complexity mn only using dynamic programming, but that is approximately equal to 2 power n. So they are NPC, right? Fine. Next application of dynamic programming is all pairs shortest path. What is the meaning of all pairs shortest path? Let me explain. I think we done already single source shortest path. What is the meaning of single source? One source to every other vertex. What will be the shortest path? But all pairs shortest path means right, first source, see, one source to everywhere, next source to everywhere, next source to everywhere. What is the meaning? Not only one source to everywhere. Single source means one to many, but when you say all pairs shortest path, many to many, what is the meaning? Right, source A to everywhere, source B to everywhere, source C to everywhere. What is the meaning? 1 to n, 2 to n, 3 to n, like that, n time n square. All between every pair you have to find out shortest path. Previously, only in the single source shortest path, only n pairs are there. What is that? A to A to B, A to C, and so on, A to n. But here, B to all, C to all, D to all. So I think n times n. So let me write now. So single source means what? This is the meaning of single source. See this one. 1 to 1, 1 to 2, 1 to 3, and so on, 1 to n. So not only this also, 2 to 1, right, and so on. See this one, and so on, right, n to 1, n to 2, and so on, n to n, n to n. So like that. This is the meaning of all pairs. This is the meaning of, so let me write, sorry for this. This is the meaning of all pairs. So 1 to everywhere shortest path, 2 to everywhere shortest path. If you do only this one, single source shortest path, right? If you do this also, like that, n time, that is called all pairs shortest path. That is called as all pairs shortest path. So how many pairs are there? N square pairs. Previously only n pairs, because 1 to all. Here all pairs, right? N square pairs are there. Next one, some people are asking, sir, how to solve this problem? See this one, one way. See this one, one way. Make sure that everyone listen. One way is going to be, isn't that all positive edge weights? Positive edge weights. Positive edge weight. Can you help me know positive edge weight? Who will find out single source shortest path? Dijkstra's. Right? Positive edge weights. Who will find out single source shortest path? Dijkstra's algorithm. So what will you do? Right? So Dijkstra's algorithm, if you apply one time, supposing that I apply Dijkstra's by taking A as source, so A to everywhere I will get. Do the same thing by taking B as source, B to everywhere you will get, like that. Do V times. If you do one time Dijkstra's, right, one vertex to everywhere shortest path, do like that V time. So finally, right, so graph contain positive edge weights only. If you want all pairs shortest path, V times apply Dijkstra's. So V into Dijkstra's algorithm one time using adjacency list and min heap, V plus E log V, right, like this. V times of Dijkstra's. That is the one way to solve this problem. One more way, see this one, one more. Suppose the graph contain positive also, negative edge weights also. So what is the answer? Positive also and negative also. Positive also and negative, and positive and negative edge weights, but not, see this one, but not negative edge weight cycle. But not negative edge weight cycle. Then what is the answer? Bellman-Ford. Then Bellman-Ford. But not negative edge weight cycle. Bellman-Ford. Bellman-Ford also single source shortest path. If you want to make all pairs, do V time. So time complexity. V times of VE. So to find out all pairs, V times of Dijkstra's in positive edge weight graph. V times of Bellman-Ford, positive negative edge weight graph, but no negative edge weight cycle, right? So these are the two ways. See the one more better idea. See this one, one more, 3. See this one, Floyd and Warshall's algorithm. Floyd and Warshall's algorithm. Right, next one is going to be Floyd-Warshall's algorithm using dynamic programming to find out all pairs shortest path. Time complexity is going to be order of VQ. Listen, time complexity is going to be order of VQ, right? So this will work for positive also, negative edge weights also, but not, see, negative edge weight cycle. Negative edge weight cycle, it don't work. Floyd-Warshall's algorithm to find out all pair shortest path in a graph which contain positive edge weights and negative edge weights and both, but not negative edge weight cycle. Time complexity V cube only. But some people are asking, right? Then what about Bellman-Ford? What is the answer? Bellman-Ford worst case if at all E value V square V power 4. What about this one? What about this one? If at all E value V square, right? What is the answer? It is the V square. It is the V cube log V, worst case. But this will take only V cube. If anyone asks you, what is the meaning of all pair shortest path? What is the answer? To do all pair shortest path algorithm, there is one algorithm called Floyd-Warshall's algorithm using dynamic programming, time complexity V cube. 3 for loops are there. It will work for positive and negative and both also. Negative edge weight cycle, no one will work. This one enough. See, from the previous information, these two algorithms came. In this particular one, right, Floyd-Warshall's algorithm you have to study. But one question also not there in the previous paper, it is more than enough. It is more than enough. If you have time, you can go through it. If you have time, you can go through it. Right? Please be careful. Floyd-Warshall's algorithm using dynamic programming, I am writing here, using dynamic programming. Using dynamic programming. Time complexity V cube. Actually, time complexity is n power n without dynamic programming because of distinct function calls, right? V cube only. So some people are asking, sir, how right recursion will happen? Something like this one. See this one? A power I, see this one? A power k ij. A power k ij. See, this I is n time, j is n time, k is n time, right? Distinct function calls n cube. Distinct function calls are n cube. Right? This is the way. Whenever Floyd-Warshall's algorithm is going on, one recursive call is there. A power k ij. K is n times will change, I is n times will change because of n vertices, j is n times will change, totally n cube. Using dynamic programming, right? Floyd-Warshall's algorithm to find out all pair shortest path, time complexity V cube. Without dynamic programming, almost like n power n because of distinct function calls. A power k ij. Right? K n time, I n time, j n time, totally n cube. This will work for positive, negative, both. Negative edge weight cycle, no one will work. Right? Just remember this. Why it came V cube? I think there are 3 variables, k, I, j or I, j, k. Totally 3 people, so n cube time.